In the next objective, we're going to talk about another type of function transformation called a reflection. In fact, there are two types of reflections, one across the x-axis, which we refer to as a vertical reflection, and then another across the y-axis, which we refer to as a horizontal reflection. So let's look at the vertical reflections first. This happens when the parent function is multiplied by -1. Let's make a note there. Parent function multiplied by -1. Again, this is going to create a reflection of the graph across the x-axis, and we refer to this as a vertical reflection. The reason we call it a vertical reflection is that the images created go up and down. The second type of reflection occurs when the input x is multiplied by -1. So the input x multiplied by -1 will create a reflection across the y-axis, and this is what we call a horizontal reflection, and that is because the images are left and right. So in these two cases, the mirror are either the x-axis in the case of a vertical reflection, right? That's our mirror or our line of reflection. And in the case of a horizontal reflection, the mirror is the y-axis. So let's explore reflections through a couple of examples. In our first example, we have f of x equals the square root of 1 minus x. We start by identifying what the parent function is. And in this case, the parent function is the square root function y equals the square root of x. I do see two transformations, and to see them more clearly, I'm going to rewrite the rule of the function in the following way. I'm going to write this as the square root of -x plus 1. Please note that -x plus 1 is equivalent to 1 minus x, but writing it in this form will help us see the two transformations, I think, more clearly. First, I see that the input x is being multiplied by -1. That's going to create a horizontal reflection. And then I see that we're adding 1 to the input x, and so that's going to create a horizontal shift. Now, the order of transformations is really important when we have multiple transformations present. I'm going to make a little note here at the bottom. The correct order of transformations in general is as follows. First, if there are any horizontal shifts or translations, that has to happen first. Second, if there are any reflections or stretches and compressions, which we'll talk about in the next objective, those happen in any order next. And last, if there are any vertical shifts, those have to happen last. So the really important ones are if you have horizontal shifting or translations, that has to happen before anything else. And if you have any vertical shifts or translations, those have to happen at the very end after everything else is done. The reflections and the stretches and compressions all can happen in any order in between. So in this case, I see two transformations. The first transformation is created when we multiply the input x by -1. So that is going to create a horizontal reflection. And that is across the y-axis, right? And before that, we do see a horizontal shift. And in this case, it would be 1 unit left because we are adding 1, which means that we're subtracting a -1, and so that will create a translation 1 unit to the left. So let's start by graphing the parent function. The parent function has an endpoint at 0, 0, then it goes through 1, 1, 4, 2, 9, 3, etc. So it's a little branch here in the first quadrant. When we moved everything 1 unit to the left, then that endpoint moves to -1, 0, and then everything shifts 1 unit to the left. And finally, we're going to create a horizontal reflection. So this branch is going to flip over the y-axis. So the endpoint is going to move over to 1, 0, and then everything else gets reflected. Oh, let me erase that. It needs to go up a little bit. 1, 2, 3. That one's off too. Let me try that again. -3, 2. All right, here we go. So that will be our final graph of the transformed